Let's do this so you have enough time to practice. I introduced this curve yesterday called the normal curve. All right, you guys had a little taste of this yesterday, but now what I'm doing is I'm adding in percents. And if you take it right down the middle here and you add up all the percents to the left, it'd be 50%. You add up all the ones to the right, it's 50%. What's at the middle? That's your, what did we call this yesterday?
Mean.
That's your, yeah, it's still staying at. That's your mean.
I bet.
And remember when we said we're going to go one standard deviation above it? All right, these are broken into halves, but everyone see where the positive one is.
Yep.
Okay, so how do you think I would get that score at one above? Same way I did yesterday, which is, and I just reviewed, which is take the mean and do what? Add what?
A deviation.
Add a standard deviation, whatever that value happens to be from my calculator. Correct. So let's go one below now. Everyone see that spot on the curve, one below. All right, so one below, how do you think I get that value? Subtract mean minus
Standard deviation.
Now I'm going to stop there. Grab your calculators now. I would like you to add all the percents that are within one standard deviation. So what am I asking you to add up? Everything here, right? Add up all the percents that are within one standard deviation for me, because that number is going to be important to us today. And I'd like you to make a note of this percent as well. What's everybody getting that's within one?
68.2.
68.2. So if you're talking within one standard deviation, that is 68.1% of scores there. Please know that number, and please know it's associated with what?
68.2.
0.2. Sorry, my bad. All good. Know that number, know what it's associated with. Let me keep going with the curve here. I'm not done. We got some studs in here. How do you think I get the score at 2 now?
Just add everything in 2.
Well, I would still take the mean, but now I add not just the standard deviation, but
twice.
add it, so 2 times the standard deviation, yes. And then over here, how do you think I would go to -2?
Subtract 2 times.
Take the mean and subtract 2 times the standard deviation. Yes, I keep adding it to go this way, keep subtracting it to go this way. All right, one last thing I need you to do, please, in your calculator. What percent of scores are within 2 standard deviations? What percent of scores are within 2 standard deviations? Add those percents up because I need you to know that number. What percent of scores are within 2?
That's a pretty high percent.
It is. So as you add up from -2 to 2, what's our percentage?
95.4.
95.4. Please know that number as well. Okay. And you'll see these numbers come up here later on in the notes. Let me just do, it doesn't come up too often, but I always want to prepare you for every possible scenario. 3 standard deviations. I'm not going to ask you to add that. I'll just give it to you. It's 99%. About 99%. It's actually 99.8, but 99 is fine.
Is there always going to be those percentages?
Yes. Yeah. Associated within 1, within 2.
Like any one of those graphs, it's always going to be one standard deviation at 68.2.
Correct. If, and this is a big if, Ian, ask your question again, because this is very important.
All of them are going to be the same.
Is it always going to be, if I hear it's within 1, is it always going to be 68.2%? If the scores are normally distributed, which we're going to start seeing here in a second. Okay, I can follow this curve. Any questions? Because I want to start using the curve and the percentages right now. All right, let's do this. I'll show you how we use the curve here. All right, a set of measures follows. Everyone circle bell curve for me. follows a bell curve. You got to lock in here for me. Circle that. That tells me I can use the curve and its percentages. Okay, I can use the percentages underneath the curve. It follows a bell curve. The mean is 80. Hey, can we place that 80 somewhere? At where? 0. We can place that 80 there. Nice. Has a mean of 80 and a standard deviation of 5. Hold off. We'll use that 5 in a second. Approximately what percent of scores fall between 75 and 80? Well, I got to figure out where 75 and 80 are on this curve. Where is 75? Where is 80? I'll add up the percents in between when I do that. How do I figure out where 75 and 80? Well, I got 80 already. Let's go back to the standard deviation. That's 5. So as I go up to 1, what did you tell me to do? Add it, right? Well, that's going to give me 85. All right, I don't want to go this way because I'm looking for 75 and 80. So as I go backwards to -1, what should I do with the 80? Subtract 5. So what's at -1? 75. So right here are all the scores that are between 75 and 80. I just need to add them up. They're asking me what percent of scores fall between those two. There they are right there. 15 and 19.1.
24. 34.1.
Everyone see where I'm getting the numbers on the curve and why I'm adding those two percentages.
Yes,
we're good there. So that's what? 34.1% of the scores. All right, we know 1 doesn't make us great. Let's keep going. A set of scores with a, circle that word term right there, normal distribution. That is the word we're really looking for that says you can now use the curve and its percents. Mean of 50, where are we throwing the 50?
Middle.
Yep, 0. Standard deviation of 7. What percent of scores fall between 36 and, ooh boy, I got to get to 36 and 64. Cripe. All right, what's that 1? 57. Add 7. Oh, no, I still got to keep going. So what's going to be at 2? That's going to be 64. Keep adding 7, right? The standard deviation. Everyone's good how to get that side. Well, how do I get 36 on the other side? Let's see, -7. I'm going to have 43 at -1. Still not there. -7 again. What's at -2? 36. Now I can do this problem one of two ways. I can legitimately, again, add up everything from -2 to 2, or this is why I say it's helpful to remember I'm within 2. What's the percentage automatically that's always within 2 standard deviations? 95.4%. And again, hey, you don't remember that in this problem? All right, well, you're going to have to add up all the percents in between here, and you'll still get 95.4. Questions before I break the bad news? You ready for this one, Tyler?
Yeah.
You don't see. You don't actually see.
There's a formula.
Stop. No.
The reference table.
Don't try to predict the future, please.
It's a piece of paper.
Oh.
All right, let's read through number 3. I'm giving this test to 120 students. Yep. Oh, what do we see? The scores approximated are a
68%
normal distribution. Yep. The mean is 72, and the standard deviation is 7. Approximately what percent of scores were 65 or higher? Oh, it's EN. I know how to do this problem. I know how to do it. So do you. But what are we missing right now?
The curve.
Where the heck's the curve?
You could reuse them.
No, I don't want. I'm not going to reuse it either. So does that mean I'm telling you to memorize the percentages? No.
It's in the calc.
Hey, oh, anybody see that curve on the formula sheet you're going to get on the Regents exam?
No.
That's useless,
So we got it.
right? That's useless. So how am I going to do this problem if I don't have that darn curve and the percentages in front?
Number.
Calculator.
Calculator's got a curve built into it already. Okay, so those last 2 problems are the last time you need to actually use a physical curve, because now we can use our calculator. All right, everyone just lock in, please, so I can show you where to go. So this is a normal distribution problem. Go to your home screen. I am no longer going to statistics because if you go down another one, you see the word distributions, and that's what we're doing, normal distributions. So please select this. And this is just so ridiculous how easy they make this for you guys.
Oh, normal.
Which one do you think we want to choose?
Normal.
Normal. And you live only there. Only there. You do not live on any other selection. No. Normal? It can't make it any easier for you now. What's it asking for? You don't need even to know that symbol, the darn words right there. It says type in the mean, please, which in this problem is
72.
Okay, so everyone type in 72. Now you don't even need to know that symbol from yesterday. They're asking for the standard deviation. 7. Everyone type in 7. You thought that was easy. Wait till you watch the next part. Now next. Now up pops this curve. Now this is where we got to start thinking a little bit. Go back to the question. What's the question asking? What percent of scores are 65 or higher? Higher than 65. So as you look at this screen right now, everyone see this one here. That would be going this way, lower. Keep looking. Go there again. See my options? It's either lower, in between, or higher. Which one do I want?
Higher.
All right, so let's select it. And then you got to tell the calculator bigger than what?
65.
Bigger than what?
65.
65. So I type in the number 65. Enter. It'll even show you on the curve everything bigger than 65.
84.
And then, whoa, the only thing you got to recognize, this is not my answer. This is my answer as a decimal. And I'm asking for a percent here, correct?
84%.
So about 84%. Okay?
Did you have to memorize this? No.
Memorize what? You have to memorize how to get it in the calculator.
No,
No,
but like-
no. Good question, Rod. Back before NumWorks days, you were given that curve on the reference sheet. It used to be on the reference sheet.
Does it matter that it was given to 120 students?
Not right now. It doesn't. It might coming up here, but right now it doesn't.
means-
Now, hey, hold on. That was multiple choice. So work is not required for multiple choice. But as we go to number 4, you just can't write down a percent without showing work. So what work do I need? Let's talk about it. Go to number 4. 425 on the SAT exam. Mean of 540. Standard deviation of 80. Got, oh, there it is. Hey, that is my signal right here. I see the term normally distributed. I'm going right to the calculator. If Sue scored a 740 on her math exam, what percent of students scored below her? All right, let's go. Let's go back. What's her mean? 540. And standard deviation of 80. Here's where you got to do a little bit of thinking. What percent of students scored below her? So which one do I want?
99%.
I want the below one right here, right? Over, below what?
740.
So 740, yep. I type in 740. I hit enter. Oh, she's a smart cookie, huh?
Just like me.
All right, so let's get the answer down because what to the nearest percent? What is the nearest percent? 99%. All right, and this is the part you're not going to like. But look, if this is a 3-point question on the Regents and you just write 99%, you're getting 1 point because it didn't show any work. All right, you only get 1 point. So what work is required to get full credit? Show that curve.
Just draw like
With literally take this curve and put it on your paper. Okay? That's what you need to show with the little markings down below. Colored in, correct. All right? So that's what you need for work on these type of questions. If it's multiple choice, no work needed. But something like here, I would need to show the curve, with the numbers underneath. Make sure you put a little line right about where 740 should be, because there should be no colored in on that part. All right, so I'm sorry, guys, but that's what we need here. I want you to get full credit. And I don't think it's that bad. Well, we got to label the bottom, yeah. Got to label the numbers. I got to know what numbers we're using. Again, guys, what I'm telling you is you got to put this curve into your notes.
Nicholas Smith. See you in night.
Oh. I'll see you there too.
Nice. You and Con already worked on matchups. We know who's starting who. Bro. Turkish nightmare.
Okay, we good? Hey, any questions? Because there's one other type of problem I need to do with you, which is going a step further than where we've been. Any issues yet? Okay, let's go one step further now. All right, so I got normally distributed, got it. Means there, standard deviations there. Will asked this question earlier, now let me answer it. There's 250 soda cans now. How many are expected? I'm not asking the percent. I'm asking for how many are expected. So watch what I do at the end. So go back, go to normal distribution, find the percent still. Let's find the percent. Go back to normal distribution, put in your mean and standard deviation here, 12 and 0.6. Which curve do I want here? Have less than 11.1. I want this one, right? Everyone's good. I want this first one less than 11.1. Okay, now be careful here. This is a trap. That's my percent as a decimal, but I'm not looking for that. I'm looking for how many cans. So about 67% of 250 are less. All right, that everyone see what I'm looking for here? Do I have the wrong one up here? People are giving me.
No, it's just 0.0. Yeah, 0.067.
So it's 6%.
Okay, so yeah, sorry. Yep, so it's about 7%. But watch what you can do here. What would you do here? Let me point. Don't write anything down. Don't write anything down. 0.0. I want to show you a trick on the calculator. 0.0668072. What do I need to do with this and the 250 to find how many cans total? I would have to multiply it, right? That's what I need you to do. Watch what you can do on your calculator.
Easy. Copy and paste.
You can copy and paste. There is a copy paste button on your calculator. So I go ahead over and highlight that. Does everyone see copy above the var button? So you're going to have to go shift var so your calculator can copy that. Now where do I do multiplication on the NumWorks calculator? So I got to go back to calculations on the home screen. And then does everyone see paste right next to it on the toolbox? So I can go shift paste. Look at that, pops right in there.
I like this calculator.
Times 250. So about how many cans? About 17 cans. So that's the only thing I worry about. I know everyone can just type our numbers in the calculator. It's a matter of, do I need the percent or how many of the cans? All right, keep going. We're almost done here. Ooh, what happens when I can't use the calculator? What happens if I can't use the calculator, right?
Must be left blank.
Ready? The mean is, okay, normally distributed, so maybe I'm thinking go to the calculator. I give you the mean's 56 and the standard deviation is 5. Here's the problem, though. I'm not asking for the percent. I am giving you the percent and want the interval back. And there's nothing on your calculator that can do that. Unfortunately, nothing on your calculator can do that. So does everyone see this problem? You know the percent. What's my interval then? But look at that percent I gave you. Look at that percent I gave you. We should have lights going off.
That's
Well, that's what?
2.
2 within 2, right? That's why I say know those numbers. We don't need the darn calculator. We can do it right here. So I know that whatever's within 2 is my answer. How do I find it now? Draw yourself a little sketch of the curve to help you out. What's in the middle? The mean, which is 56. All right, how do I go over 1? How do I go over 1? In the positive direction?
Subtract 1.
Add 5. So that gives me 61, but that's one standard deviation. I need to go over another, which is 66. All right, there's positive 2. How do I go to negative 2? Subtract 5 twice. So 51 and... So what's my interval that contains 95.4%? 46 to 66 is the interval where 95.4%. Will I give you any other numbers? Yes. I might give you 68.2. And that's what? Within 1. Other than that, that's where I'm stopping, guys. All right, I'm not going to give you any other percentages. Questions, comments? I'm not going to have you do number 7. All right, I want you in the mode of using your guess. I'm not going to have you do number 7. Don't worry about it. All right, I want you in the mode of using your calculator if you can. All right, so let's go. Use your calculators. Let's start using your calculators. Mom, don't waste my time here. Let's go.